national attention. And in case we have forgotten, because we keep hearing that 2014 has been the warmest year on record, I asked the chair, you know what this is? It's a snowball. And that's just from outside here. So it's very, very cold out, very unseasonal. So here, Mr. President, catch this.
That was Senator James Inhofe from the floor of the Senate. While that demonstration wasn't particularly compelling for reasons that should probably be obvious, he does accidentally raise an interesting question. If winters are on average getting warmer in response to global climate change, why does it seem like snowstorms are getting more intense? The relationship between the rising global temperature versus the amount of CO2 in the atmosphere has been evident for a long time. As represented in the graph, the global temperature has increased nearly 2 degrees over the last 100 years, and depending on future human emissions, is projected to increase 1 to 3 degrees more. How this can cause warmer summers and intense heat waves like we saw in Europe in 2022 is fairly intuitive, but why would a warmer globe ever result in intense snowstorms?
If you've been watching the news recently during any of these freak cooling events, a term you've certainly been hearing more and more about is what's known as the polar vortex.
Polar vortex.
Polar vortex.
A term that's being used more often in the media is polar vortex.
But what is the polar vortex anyway, and how does it affect weather? The polar vortex is a ring of cold air that blows around the North Pole that is normally contained by the jet stream. However, this air can escape in a variety of ways. One mechanism scientists have been aware of since the 1950s is known as a sudden stratospheric warming event, where the movement of warm air destabilizes the polar vortex and causes it to fragment into smaller pieces. These pockets of cold air can then be carried south, causing abnormally cold winters. However, because they only occur a few times every decade, scientists have been divided on whether these sudden stratospheric warming events have actually been occurring more frequently, and uncertain that it would be anthropogenic if they were. In 2021, though, a new paper was released in the journal Science that proposed that a lesser-known mechanism should perhaps be considered. The researchers used machine learning models of past atmospheric data to determine that many recent cooling events probably were not caused by the breaking part of the polar vortex, but the stretching of it. When the jet stream that usually keeps the vortex contained is weakened, cold air is allowed to expand into the territory that it once occupied. The rapid chilling caused by this stretching is quite similar to the chilling events caused by sudden stratospheric warming, but without having the polar vortex have to break apart at all. Furthermore, their model found strong evidence that this specific kind of cooling event has been becoming more frequent with time, and more recent studies seem to confirm this.
This phenomena seems to explain conditions such as we saw in Texas in February of 2021, where temperatures reached as low as 6 degrees Fahrenheit for 6 to 9 days, labeled as the freeze, placing extraordinary stress on their isolated electrical grid. This caused outages all across the state, $80 to $130 billion in damage, and at least 210 deaths. So even though the global temperature is on average rising each year, it's inaccurate to think of climate change as a purely warming phenomena, and more of an intensification of existing weather conditions.